Hello friends, welcome to Breno Sam. In this video we will learn about rational numbers, what rational numbers are. We will see different examples of rational number and we will see different operations and what are the properties of operation on rational numbers. And if you like this video, please don't forget to like and subscribe. So let's start learning about rational numbers. Before we start learning about rational number, let's have a quick recap of natural number, whole numbers, integers and fractions. So when we need to count objects around us, we need numbers, and these numbers are called natural number, like 1, 2, 3, 4. If we add 0 to natural numbers, they become whole number. If we add negative natural numbers to whole numbers, they become integer, like -3, -2, -1. If we add negative natural numbers to whole number, and these are whole number, it becomes integers. And if the number is in the form of a upon b, like if the number is in the form is like 3 by 4, 1 by 2, 5 by 7, so it is called fraction. So now let's learn why do we need rational numbers and what they are. So now let us understand the concept of rational number with the help of an example. Say for example, from a point, if a person is moving towards east and he moved 3 by 4 kilometer from east, so we can denote this distance by 3 by 4. If we want to move from this point to south direction, then how we will denote this? If we move 3 by 4 kilometer to south to west direction, so from this point we will have to denote this as -3 by 4, this distance as -3 by 4 kilometer. So it is possible to denote the distance in fraction with minus sign. So this number is neither an integer nor a fraction. It is a rational number. This 3 by 4, -3 by 4. So we need to extend our number system to include rational numbers also. So now let's have the definition of rational number. The word rational number arises from the term ratio. We all know that the ratio, like this 3:2, can be written as 3 by 2, where 3 and 2 are natural numbers. Similarly, rational numbers is the ratio of two integers. Say for example, if there are two integers p and q, so rational numbers can be written as p by q. So a rational number is defined as a number that can be expressed in the form of p by q, where p and q are integers and q is not equals to 0. So let us rewrite this definition again. Rational number is the number that can be expressed in the form of p by q, where p and q are integers and where q is not equals to 0. So examples of rational numbers are -3 by 4. It is a rational number because the denominator -3 is an integer and 4 is also an integer. 1 by 2, again a rational number. 1 is integer, 2 is integer, and 2 is not equals to 0. All the fractions are rational numbers because the denominator and the numerator, like for example 4 by 5, it's a fraction, but it is also a rational number because 4 is also an integer and 5 is an integer, and 5 is not equals to 0, so it's a rational number. All fractions are rational numbers. Likewise, all integers are rational number. Let's understand this by an example. Say for example minus 3 is an integer. We can also write minus 3 as minus 3 by 1, where minus 3 is an integer and 1 is also an integer and 1 is not equals to 0. So in this minus 3 can also be written as minus 3 by 1, which is a rational number. So all integers are also rational numbers. Now one more thing is 0 is also a rational number. Let's understand it with an example. If we write 0, we can also write it as 0 by 1, 0 by 100, 0 by minus 3. So these are all rational numbers. So 0 is also and one more thing, decimal numbers are also rational numbers. If for example we have a decimal number 0.5, we can write it as 0.5 by 10, 5 by 10. So 5 by 10 is a rational number. Similarly, we can make it in standard form 1 by 2. It will 5 by 10 will be equals to 1 by 2. So 1 by 2 is also a rational number. So all decimal numbers are rational number. So these are the points that needs to be remembered while learning about rational numbers. One more thing is we can also represent rational number on number line. Likewise we do for integers. So if we want 1 by 2 rational number on the line, we can represent it here. Similarly minus 1 by 2 can be represented here, and in between two rational numbers there are many unending rational numbers. Likewise minus 1 by 2 to 1 by 2 there may be many rational numbers like minus 1 by 3, 1 by 3, and the list is never ending. So rational numbers can be represented on number line, and there are n number unending rational numbers between two rational numbers. Now let's see what is the standard form of rational number. A rational number is said to be in the standard form if its denominator is a positive integer and its numerator and denominator should be in such form that there should not be any common factor between them except 1. Like say for example this minus 45 by 30, this rational number is not in its standard form. We have to reduce it in its standard form by dividing it by its HCF. For HCF of 45 and 30 is 15. So if we divide this number, the numerator and the denominator by 15, so we will get minus 3 by 2. So this number is in its standard form. Here 2 is a positive integer and there is only one common factor between 3 and 2, which is 1. So this number is in standard form. So for reducing the rational number in standard form, we need to divide the numerator and the denominator by their HCF. And we know we can divide, multiply, subtract, and add rational numbers. Now we will be studying the properties of these four operations on rational numbers. Let's see the properties. First, let's see the closure property on addition. See, for example, if we have two rational numbers 1 by 2 and 2 by 3. If we will add these rational numbers, what we will get? 6, 3 to the 6, 2, and 3, 2 3s are 6, so this is 3, and 3 to the 6, 4. We will get 7 by 6. It is also a rational number. So by adding two rational number, we will get another rational number. So it is proved that adding two rational number, we get another rational number. So rational number is closed in addition, under addition. So we can say if we add two rational numbers A and B, so A plus B, the result of the addition, that is A plus B, will also be a rational number. So rational numbers are closed under additions. Now let's see if rational numbers are closed under subtraction. So if there are two rational number 1 by 2 and 1 by 3, if we subtract them, what we will get? We will get another rational number. So rational numbers are closed under subtraction also. If we will multiply two rational numbers, we will get another rational number. Rational numbers are closed under multiplication. Similarly, if we divide two rational numbers, we will get another rational number. So rational number are closed under division also. But there is an exception in closed under division. Say for example, if 1 by 2 is a rational number and if we divide it by 0, we will get an undefined number, which is not a rational number obviously. So if rational numbers are divided by rational number except 0. So they are closed under division, but not by dividing by 0. So we can see, so rational numbers are not closed under division when we include 0 also. If we exclude 0, they are closed. So in all, the closure property holds true in when in under addition of rational numbers, under subtraction, under multiplication, but not under division, because rational numbers, if divided by 0, which is also a rational number, they will result in an undefined number, so they are not closed under division. So this is the summary of closure property. Now let's have look on another properties. Now let's see the commutative property. Two rational numbers are commutative in terms of addition if a and b are two rational numbers. If a plus b will be equals to b plus a, then we will say that rational numbers are commutative under addition. But we have to check it if this property holds true. So let's take two rational number 1 by 2 plus 1 by 3. Let's find the sum of these two. It is 5 by 6. Now let's reverse the order of these rational number. Say 1 by 3 plus 1 by 2. Now find the addition. So by example we found that these two, if we change the order of the two rational numbers over addition, we get the same result. So we can say that rational numbers are commutative under addition. Now let's check this for subtraction. Rational numbers will be commutative for subtraction if we get a minus b equals to b minus a. Let's check it with the help of an example. Say for example we have 1 by 2 minus 1 by 3. Let's check the result. Now exchange the order of the numbers. 1 by 3 minus 1 by 2. We will get minus 1 by 6. So we can say that rational numbers are not commutative under subtraction, because we are not getting same results for the subtraction of two rational numbers. So they are not commutative under subtraction. Now we will be checking if rational numbers are commutative under multiplication. So for this we have to prove that a cross b is equal to b cross a. So let's prove it with an example. Say there are two rational numbers 3 by 4 and one more rational number 5 by 3. Let's multiply them. We will get 15 by 12. Now reverse the order of these rational numbers. 5 by 3 cross 3 by 4. We will again get 15 by 12. So these both results are same. So we can say that these two rational numbers are commutative. Now let's check commutative property for division. So let's take two rational numbers 1 by 3 divided by 1 by 5. So the result will be 5 by 3. Now reverse the order. 1 by 5 divided by 1 by 3, we will get 3 by 5. So these two results are not same. So rational numbers a divided by b is not equal to b divided by a. So division property does not hold true for commutative property. So we have seen that for commutative property, rational numbers are commutative under addition. Yes, they are commutative under addition. For subtraction, they are not commutative. For multiplication, we have seen that they are commutative. For division, they are again not commutative. Now let's see the last property of the operation of rational numbers. Now let's check associative property over addition. So for proving that rational numbers are associative over addition, we have to prove that A plus B plus C should be equals to A plus B plus C, where A, B, C are rational numbers. So we will prove it with the help of an example. Let us take three rational numbers 1 by 2. Let us find the sum of these numbers 1 by 2 plus 1 by 3 plus 1 by 4. It will be equals to 13 by 24. Let us change the position of the braces and let us find the result of these equations. Again the result will be same. So we can say that rational numbers are commutative over addition. So rational numbers are commutative over additions. Associative over addition. Now let's check if they are associative over subtraction. Again we will do this with the help of an example. So for proving that rational numbers are associative with subtraction, we have to prove that A minus B minus C is equal to A minus B minus C. So let's again take the same example of three rational numbers 1 by 2, 1 by 3, 1 by 4. 1 upon 2 minus 1 upon 3 minus 1 upon 4. The result will be equals to 5 by 12. And if we change the position of the braces, 1 upon 2 minus 1 by 3 minus 1 by 4, result is 1 by 12, minus 1 by 12. So rational numbers are not associative over subtraction. Now let's check if rational numbers are associative over multiplication. So let's find 1 by 2 into 1 by 3 into 1 by 4. Result will be 1 by 24. If we change the position of the braces, 1 by 2, 1 by 3 into 1 by 4, again we will get the same result. So we found that rational numbers are associative over multiplication. Let's test the same for division. We will be using the same rational numbers. So this will not be equals to results are not same. So rational numbers are not associative over division. So this does not hold true for division. So rational numbers are not associative for division. So these are the properties of operation of rational numbers. So in sum, I have made this table. So rational numbers are not closed under division and they are not commutative under subtraction and division. and rational numbers are not associative over subtraction and division. So this is all for this video. In the next video we will be learning about additive identity for rational numbers and multiplicative identity of rational numbers, inverse reciprocal or inverse rational numbers, and we will be learning about the representation of rational numbers over number line, and we will be finding the mean of rational numbers, and we will be knowing that there are countless number of rational numbers between two rational numbers. Thanks for now. If you like my video, please don't forget to subscribe and like, and don't forget to share it with your friends. Thank you.